Hi, and welcome to episode 16 of my free Java video course. My name is Markus Biel. In this episode, I'm going to talk about interfaces in Java. Well, interfaces are probably the most powerful feature of object-oriented languages. Before I continue, first of all, some organizational stuff. So this video is divided into three parts. Part 1, I will first of all talk about the definition, what does actually the word interface mean, and tell you a bit about the history, like how were interfaces introduced into Java. I'll make this part as short as I can, not to put you to sleep. And then second, we'll jump into my IDE, we'll do a short coding session, and I show you how to practically use interfaces in Java. And then last but not least, I'll do a short discussion about the pros and cons of interfaces from a clean coder perspective. Okay, so let's directly jump into the topic, interface. So what does interface actually mean? So I've opened up the dictionary page, and the definition is an interface is the point of interconnection between entities. And interfaces do not only exist in programming, but also in all other kinds of areas, for example in chemistry and physics. And there it's defined as a thin layer or boundary between different substances. And I think this perfectly also applies to interfaces in object-oriented languages and Java, because it's really a very thin layer. You will see there's not much code needed to define an interface, and it also forms a boundary. When I say boundary, think of something like the Chinese wall, which was a big protection from the hordes that were invading from the north. And this is also what an interface is. It can protect a class from other classes. But more of this later. Okay. And then maybe we should also look at the object-oriented point of view. So in object-oriented programming, it's a piece of code defining a set of operations that other code must implement. So yes, all this holds true for interfaces in Java. But now enough of the definition. Let's have a look at the history. For this, I actually had to do some research on the internet. Finally, I found this page here from Oracle, where Oracle says the concept of an interface in the Java language was borrowed from the Objective-C concept of a protocol. Well, pretty much everyone says or thinks that Java was actually the first language introducing interfaces. Well, actually, Oracle itself says that this is not true. It was borrowed from Objective-C. I find this quite interesting. Objective-C, I thought we should also have a look on Objective-C then. So I found this page here saying Brad Cox and Tom Love created the Objective-C programming language in the early 1980s. So actually much older than Java. Java was released, as far as I know, in 1995, so 15 years later. In an effort to get people to write cleaner, more modular, and clearly separated code. Yeah, that sounds actually quite good. Now, what is interesting is here this paragraph also says interfaces were introduced to Java to enhance Java's single inheritance model. So whatever single inheritance model means, they didn't say they had introduced the interfaces to get more cleaner, more modular, and clearly separated code. There is a different reason. Well, I haven't told you what inheritance means yet, and this for a reason, because, well, Java was released in 1995, as said before, and now we have 2015, 20 years later actually. In the meantime, especially the clean code community does not believe so much in inheritance anymore, because of course inheritance has a lot of advantages, but also many disadvantages. About this I'll tell you in one of the next episodes when I'm going to talk about inheritance in Java. But anyway, so when Java was introduced, Java is the successor of C++, we could say, and C++ still had a model using multiple inheritance. So multiple inheritance is even more complicated than single inheritance, and here they write, multiple inheritance created too many problems for programmers as well as compiler writers, because it's actually not so easy to implement multiple inheritance into a compiler. So it seems, because they did not support multiple inheritance, they added interfaces to Java as like a replacement for multiple inheritance, to like fix that Java did not support multiple inheritance. And this is quite funny, and let me say it in different words. I would say it seems like the really powerful feature of interfaces was introduced into Java by kind of accident, because they, as said before, they didn't think about cleaner, more modular, clearly separated code, but mostly just to have a way of having something similar to multiple inheritance. Okay, let's stop here and jump directly into my IDE, because I felt you were already falling asleep. So here, this is my car service test that I've used in earlier episodes also. I've added this should demonstrate interfaces method, as the name implies, just for demonstration purposes. I'm still using the car service that I've implemented also in one of the earlier episodes, and I've added a drive method to it. So the idea is to have a service class, and when I call the drive method, that this should like start the engines of several cars and make them drive. So for this, in my car service, I have now a method drive. It creates, first of all, 3 different cars. I mean, this is just an example. Imagine there were hundreds of cars. And now I call the drive method on each of these cars. Okay, actually, all these classes are in the same package. This is why I don't have to import any class. But imagine each class would be in a different package. We would have to import each class separately, like BMW and Porsche and Mercedes and so on. So what we say here, there's actually this car service at the moment is really deeply coupled to these car classes. This is something that we don't want. More about this later. And also you see we need a lot of code to make all the cars drive. And this is something that we want to improve with using interfaces. Now, what is an interface? Well, an interface is also like an abstract type, a definition what this type should be able to do. In our case, we have, and I'm already saying it, 3 different cars, and all these cars can drive. And you see it already, I have 3 different drive methods. The way how they are driving might be different, because of course a BMW has a different engine than a Porsche, and again a different engine than a Mercedes. But they have some certain specifics, like for example they would all have 4 wheels and they can all drive, which we can make something like a contract of. So in this way, let us introduce an interface, and I have prepared something here, car.java. So far we only have the package declaration, we have to extend that. So let's start. Let's start as if we would write a class. So let's say public class car, and then opening and closing curly brace, and now public void drive. Okay. And then in here we could do something. Well, the problem is if we do it like this is not going to work, because then all the different types will have to drive the same way. But this is not what we want. For example, here in Porsche, I have implemented already the drive method. This is just a stupid example. I still warn you, hardly ever to use system.out.println. But here for our example, I just wanted to show you that each method is implemented in a different way. Here it says Mercedes driving, there it says Porsche driving. The BMW actually even has 3 different methods. These ones we'll actually use at a later time. And it also has the drive method, which says BMW driving. Okay. So now, maybe before I'm going to continue with doing the interface, we could also try to execute the code as it is. Let's do this now, just so that you see the code should be running by now already. So it says BMW driving, Porsche driving, Mercedes driving. So what I want to achieve is exactly the same, just using interfaces with less and more readable code. By the way, exit code 0 means everything is fine. If there is a problem, an exception thrown, it would be exit code 1. Okay. So back to what at the moment is still a class. Now there's a very easy way to make this an interface, and this is, I say, interface. But now it seems there is still a problem. It says interface methods cannot have a body. Well, what is a body? The body is this part here in blue. So the body is actually the method implementation. A method also has a method signature. This on top here is called the method signature. Public, void, and the name of the method is drive. Okay, sorry. So it seems like it cannot have a body. How is that? Well, I guess it even makes sense, because we said we just want to have a definition, like a contract, but we don't want to actually implement it. The implementation will be done by the specific implementations by BMW, by Porsche, and by Mercedes. And we have already done the implementations. So let me remove the body. Now there is still something wrong, and you see it here. My IDE even says it. It wants now the semicolon, because the semicolon now says I'm finished, I'm done. This is all I want to say here. So now we have an abstract definition of a method that other classes may implement. And when they implement the interface car, we can also say they play the role of a car. Because actually a class can implement more than one interface. A class can implement any number of interfaces. And remember, before I spoke about multiple inheritance. Well, multiple this is why it's similar, because it also allows to have like multiple implementations in a way, but more of this later. So a class can also implement multiple interfaces. Okay, and when I click here, you also see modifier public is redundant. Why is it redundant? Because by definition, all methods that we define in an interface must be public. They are always public. So even if I remove it, well, if you still remember the episode I did on the visibility modifiers, you might now think, well, now that there is no modifier defined, it must be of default or package level visibility. No, it is still of public visibility, because a method is always of public visibility. Another modifier that is implicitly here is abstract. I can put it. Abstract just means what we have here, that the method is not implemented and that it just consists of the method signature and that the body is left away and that we have the semicolon here. So also this is redundant. We can and we should remove it. Always define your methods without public and without abstract. You should just know that implicitly they're there. Okay, and then there's one more thing you can do in an interface, but I warn you not to do it. This is actually an anti-pattern, but still, just to be complete, let me show you. And this is, you can add public static final, so you can add constants. For example, max speed, I don't know, 320. And however, you shouldn't do so. And when you think about it, I guess you will easily find out why. Because, for example, the BMW might only do a max speed of 240. Porsche, yeah, maybe the Porsche can maybe do 320, but maybe also even more. The Mercedes, I don't know. So this is actually not part of this should not be part of the interface, because this is an implementation detail, and such an implementation detail should be hidden within the class, or even better, in an enum. About this, let me also shortly show you a little page I found on the web, and this is here. It is on the page of Sonar. Well, actually it's called SonarQube. SonarQube is really a very cool tool. It's actually one of my favorite tools for static code quality analysis. I'm pretty sure very soon I'll do an episode on SonarQube alone. For now, let me keep this as short as possible, because we still want to talk about interfaces. But in this SonarQube, it's actually a rule that checks that you don't use constants in an interface. Here it says constants should not be defined in an interface, and there is also a very smart, cool guy, Joshua Bloch, the author of Effective Java, which is, by the way, also a must-read. I have a link to that book on my blog on marcus-biel.com, where you can directly buy it from Amazon. So if you have the time, you can also read all this, but I think I already explained the important parts. Here we can also look at it. So non-compliant code is to define the variables directly in the interface, and you see here they even didn't say public, static, and final, because this is again every variable you define is implicitly a constant, so you don't even have to say public, static, final. But this is not good anyway. The much better solution is to use an enum. We have talked about enums already, so I won't go in more detail here. Another possibility which I would not recommend, you can also have something called constant classes, which you make final, and then in the class you have the public, static, final constants. This is possible, but it's always better to have small enums, because usually what happens is in these constant classes they would grow and contain all kinds of different constants, while this only contains the constants of the status here. And also, talked about this when I talked about enums, is type safe. Well, here you could change any number. Okay. So anyway, so now back to our code. So here you already see it's redundant. All this is redundant and should be removed. But this should also be removed, as I said before, because this is an implementation detail. This is not part of our contract, because the car should just define what needs to get done, what behavior a class implementing that behavior has, like it should drive, but the way how it drives, if it drives fast or slow, this is part of the class and not part of the interface. This is really important when you want to do clean coding. Okay, so now let us implement and use the interface. So now, when I say implements car, when you can now use BMW as a car, and when you do so, BMW plays the role of being a car. And as I said before, you can also implement several interfaces, which we're going to do very soon. But first of all, let me finish this. Porsche implements car and Mercedes implements car. Well, the compiler was directly happy. I hadn't got to do anything. Oh, implements car. Because the work I've done beforehand, implementing the method. Well, normally, I did this just to be faster in my here code example. You would do it like this. You define a class, you say it implements an interface, and then you see I already have a problem with the compiler, which tells me I have to implement the abstract method drive. Okay, and then you do this, and the compiler is happy. It has to be exactly like defined in the interface. You cannot, for example, say int as a return value, because this is not how it was defined in the interface. Okay, now let me also show you. Oh, there's still a problem with car. It seems there's the curly brace missing somehow. Okay, seems like I probably deleted too much. Okay, see how small this is? Well, actually, by the way, an interface should have at least one method. Well, this is also not true. There are even something called marker interfaces that don't even contain a single method. This is a specialty, which I'm not going to go in detail now. But usually they would have at least one method, and maybe even many more methods. But again, I want to warn you, I see often interfaces with tens of hundreds of methods, and sometimes it's just too much. It's better to have many interfaces and to have your classes implement several interfaces at once, so that you can decide what role your class is going to play. And now let's implement more interfaces in here. I've already prepared it again, adding these methods, because I have also more interfaces. One interface is the loggable interface, which I defined. The idea for such an interface is, for example, you want to do logging. You want to log several different objects. Could have cars, persons, whatsoever. Everything can be loggable. And I defined that in order to be loggable, such a class must implement a method called message, which I then later in my logging framework can call, because I know that whenever I have a class that implements loggable, it will then have a message method that I can call, and it returns me a string that should be used for logging purposes. Then also, well, it took me a while to come up with examples, because What other roles could a car play? I said it could also be a property, and such a property would have an owner. For example, the owner of the BMW I made myself. I mean, I want to have a BMW, how cool is that? And one more interface. I said, I just came up with the idea, we could also have a role of being an asset. An asset would have a value. And so my BMW also has a value. So I can now easily say implements loggable. I think this one I have not implemented yet, and I still have to do. No, not twice. Implements car, comma loggable, comma asset, comma property. The order doesn't matter. But now you see I've implemented already the value method and the owner method. The message method I still have to implement. And as I said before, the order is not controlled, so I can put it in any order, message, and yeah. So here, let me just return something. I'm the car of Markus. Okay, and now I have a class implementing 1, 2, 3, 4 different interfaces. Okay, now let's use my classes implementing the interfaces. For this, we go back into my car service. What I can already do is now my variable, my reference variable is at the moment of type BMW, the class. So my BMW can do everything that a BMW can do, which at the moment is drive, message, owner, value. These are methods that we inherit. See, there is inheritance already from the object class. More of this very soon. But these were the classes that we have directly implemented in the BMW class. So I can use all of them. Oh, let me show you a message. We can use them. Now, what I can also do is, now that I've implemented the car interface, I can say I create an object of type BMW, but I put a reference on it of type car. And now this will change the behavior. Now I can just call drive on it, because now my BMW just plays the role of a car. I can also say loggable, and then I will not be able to drive the car, because in the context of logging, I don't care about driving. All I care is about logging, and for logging I would need such a message. Okay. So now let me make all these cars. And this is also something you should do. I mean, the object is the object, but the variable, when you have an interface, always try to like reference with an interface to the object, because this way you can more easily exchange your code. Like imagine the BMW would come as an argument to the method. Now at the moment we have these three cars. Imagine at a later time someone invents a very cool Markus car. Then when the method is operating on the car interface type, this method will work even with new classes introduced without even knowing them at the time we wrote our car service. So whenever possible, use the interface type. Okay. So now I want to have a for each loop, and for this let me put all these cars into a car array. We've also already talked about array. So I call this cars equals to, and now the short definition, and I can even do it on the fly to make it even more shorter. New BMW, new Porsche, New Mercedes. Okay. And now on this array, I can now easily iterate. And I can now say car.drive. And well, as said before, each car will drive differently, but this will be handled by the object. Now our car service does not know any specific implementation anymore. This is decoupling. The code is not coupled so much to the specific implementations. My car service, all that it uses, all that it knows is now the car interface. Okay, and with these few lines, I iterate over all the cars and I drive them. Let's execute this code too and have a look if it works. Yeah, see, this is exactly the same as before. My BMW is driving, my Porsche is driving, and my Mercedes is driving. Now let's also have a look at the car reference. As you see, we can only execute drive on it. That is defined by the car interface. I mean, we do have a BMW as the first element in our array, but this at line 10 we don't know. All we know is we have an array of cars. Okay, so we cannot call any BMW specific method in here. I can also not say BMW because this is not compatible. We need a car, and we don't need a BMW because this array is of type car. Okay, so let me fix that. Okay, so I think this pretty much rounds up my explanation of interfaces in Java, a really cool feature. And now let's have a discussion about the pros and cons, about the advantages and disadvantages of interfaces in Java. Well, first of all, let's start with the disadvantages. And actually, I can tell you there are not so many. Well, you see, for every interface that I introduce, I have to type down this code. And of course, this is here not much. It could be, of course, much more. So, and each class that wants to use an interface has to implement this interface. So there is some added complexity. Also in my car service, I'm using now the car interface. And whenever you introduce complexity, this complexity must be justified. So if it makes sense, if it helps us with something, for example here, I'm now able to easily iterate over all the cars, and imagine there could be many more, but my for loop would just be the same. So this would be, for example, a justification. But my car service at the moment does not implement an interface. Well, actually, this is kind of an exception to the rule. Most services should implement an interface. Very often this makes sense because it's specifically for testing, so that you can exchange the concrete implementation. Just here, in my example, it does not make sense because I just want to explain you interfaces and I want to have it really short and neat and not too complicated. And I know I will only have this one class here for demonstration purposes, so why would I implement an interface here? So at the moment I don't see a reason to make my car service implement an interface. Sometimes, of course, there are corner cases where I'm not sure. My personal point of view there is, if I know that for the next months I'm not going to need the interface then I might probably leave it away, because code, I mean, it lives. You are allowed, you can change it, you can refactor your code. So if at a later time it turns out you need the interface, then add it at a later time. Just don't do arbitrary decisions. There are people that they love interfaces, and for this reason they do something I would call interfaceritis, like an illness, blindly adding an interface, implementing an interface always, just because. And I think this is not too smart. And then really interfaces can be a disadvantage because they just make everything more complex. But now this is already pretty much it. To the advantages. So the advantages, I think a few ones are already mentioned while explaining the interface. Probably one of the most important ones is that it decouples your code, as I explained before. Like now, the car service only uses the car. Well, no, I was actually lying. Sorry. Of course, as it is implemented at the moment, we still say new BMW, new Porsche, new Mercedes. So of course, at the moment, it would still be coupled, but normally, of course, you would also not do it like this. What you would usually do is you forward an array that is already filled, and only then, now our car service is not coupled to the specific implementations. So it really allows to decouple your code much better than without interfaces. And this decoupling also helps with other things, for example, team cooperation. Imagine you have a big team of 10, 20, 30 developers, and you have a big project that you have to work on for weeks or months. And then you would probably form smaller sub-teams, and then each sub-team would work on a specific area. For example, one team in our example here could work on the car service, while there would be another team implementing different car types. Now the problem is the car service is then or might be dependent on specific car implementations to test it. And on the other hand, the team that implements the different car types might need a car service for testing and for integrating their code with the other code. So it's like each team is dependent on the other team, and so each team blocks the other team, so nothing can be finished. And interfaces can be a solution to the problem, because when you introduce an interface here, for example, in this case for the car service, then the team implementing the different cars would just do a very stupid dummy implementation, something similar like I did here, where you don't have real code, but just something where you see it's working. And then the other team can independently also work on their code and also add dummy implementations where needed. And only when both are finished, they can be brought together. So interfaces really help in team cooperation. And then next advantage is interfaces really increase your flexibility, because as you see, as I have changed it now, we have the cars array as a parameter to our drive method. So actually at runtime, in this case in our test method, we have this drive method. So now at runtime I could have some condition. If it's sunny, just making this up, then I want to drive in my Porsche, and so I create a Porsche here. So I would say car, and then I would say if sunny, car equals to new Porsche, and else if it's not sunny, well, I hope I had so many cars, then I would say I take the BMW instead, because it's better for rainy weather. New, of course. And now well, I don't want to make an array. Let me change the method. And I don't implement Sunny now, so I just say true here, just to have it simple. So in this case now, a Porsche would be called. And in my drive method, to make this work, I make this a car to have it simple. And I would call drive. So now at runtime, we would decide what kind of car this is. So this really adds a lot of power to our code. So it might be a Porsche and it might be a BMW that is given to the drive method. Really cool feature. Okay. I guess there are many more advantages of interfaces. Let me know if you have more to add. But I think this is enough for the moment so that you get an idea of what interfaces are and all the advantages interfaces have. Just also again the warning, don't fall into a interface-aritis illness. This would also be not wise, but I think this pretty much rounds it up. So thank you for watching. As always, I would be very happy if you could leave a comment below this video in YouTube. You can also subscribe to my YouTube channel. And last but not least, of course, you can like the video. And then see you next time. Bye.